Good day, guys. Welcome to another new semester. My name is Mubarak Ukashat, and I will be helping you with your homework and recitation problems. This is homework 1, and we're going to start with the vectors in this part of the homework. And the first question on Focus on Concept, question 01, said, during a relay race, runner A runs a certain distance due north and then hands off the baton to runner B, who runs for the same distance in the direction southeast or south of east. So the two displacement vectors A and B can be added together to give a resultant vector R. Which drawing correctly shows the resultant vector? So this is the question. They're looking for the drawing. So A is going due north, B is going, south of east, like this. So they're looking for the resultant. So the resultant vector of any two vectors always starts from the tail of the first to the head of the last. That's the trick. So this is the first A, this is the last B. So the resultant is supposed to start from the tail of A to the head of B. And that is only correct after you have added A and B tail to head. So A and B is tail to head or head to tail. If I switch B's head here, then that won't be correct. So it has to be tail, head, tail, head. Then the resultant goes from the tail of A to the head of B. So I have to look for which one is the correct one. From the tail to the head. So this one is going from the head to the tail. So this is wrong. So the correct one is number 4, that goes from the tail of A to the head of B. So that is the correct answer for this case. Okay? Okay. So let's go to the next problem. And the next problem says, question 03, focus on concepts. Suppose that vector A has a magnitude of 3 kilometers and is directed due north, and suppose that vector B has a magnitude of 4 kilometers and is directed due east, as shown. So what is the magnitude of resultant vector R? So they're looking for the resultant. You see, the resultant always starts from the beginning one and ends with the head on the last one. So you're just going to solve the math. So here I have like this. So A has 3 kilometers, so I put 3 kilometers here, and B has 4 kilometers. So A, B, I'm looking for R. So this is a right angle triangle. So here I'm going to use the Pythagoras rule. Pythagoras, that says that if I have a right angle triangle, the square of the other sides summed together is equal to the square of the hypotenuse. So that gives me that 3 square plus 4 square equals R square. So R square is 3 square 9 plus 16, which is 25. So R is the square root of 25. So the magnitude is just 5 kilometers. So if they have asked us for a direction, then we'll have to get some angle. And any angle you get is fine so long as you describe it correctly. Okay? So the magnitude there is 5 kilometers. That will be the correct answer for that one. Okay, let's go to the next question. The next question says the drawing shows two displacements, 3 kilometers due north, and 4 kilometers due east, exactly the same thing, and the corresponding resultant vector R. What is the angle theta that R makes with respect due north? So they're looking for this angle theta. So now you have opposite and adjacent, so you can use tangent of theta, so you can say tan theta is opposite of the angle, which is 4 over adjacent, the one that connects the angle to 90 degrees. 3, that gives us 1.333. Is that okay? So theta is the tan inverse of 1.333. Is that okay? So you take your calculator, make sure you have your calculator with you, and that should give you 53.13 degrees. So let's verify that. That's 53.13. So make sure you have your calculator and you know how to use it. So you're going to put shift tan, that's tan inverse, 1.333. Is that okay? Okay. $53.1. Excuse me. Yep. So that becomes your answer, okay? That becomes your answer. So that's the correct answer for this problem. So we'll go to the next one. The next problem says the drawing shows three displacement vectors A, B, and C, which are added in a tail-to-head fashion. The resultant vector is labeled R, which drawing below shows the correct resultant vector A plus B minus C. So this is A, B, C is going this way. Minus C will be reverse. So you just flip this the other way. That will be minus C. And the resultant will go from here to that minus C part. It still has to be tail to head. You don't flip minus C and still put the head of minus C here and the tail this way. No. It's still tail to head. The tail will be here. You just move the head to the other side. That's minus C, since plus C is going this way. And the new resultant will be from the tail of A to the head of minus C. Okay, so this is wrong. So let's see what this one is. This is A, this is minus B, and plus C. So that's not what we want. This is A plus B minus C. So this is the correct one. This one is A minus B minus C. So this is the one that is A plus B minus C. So that is that one. So the correct one is number 2 for this case. Okay, now let's go to the next problem. I'm going to wipe this board off. So the next problem says that a person drives a car for a distance of 450 meters. The displacement A of the car is illustrated in the drawing. What are the scalar components of the displacement vector? So it's going 450 towards this side, negative y-axis. It doesn't have any x-axis. So the x component is going to be 0. So if it was in between somewhere here or here or here or there, then it will have an x and a y component. But since it's along the y, it has no x component. If a vector is along the x, it has no y component. If it's along the y, it has no x component. So we have ax to be 0 for sure. So this is not right. Ax 0, that is right. Ax 0, that is right. Good. So we are going to choose between these two. It's going to be negative y-axis. So ay is minus the magnitude, 450. So minus 4, this is the correct one. Plus 450 will be going up. So this one is wrong. So the correct one is ax 0 component and ay minus 450 meters. So that will be the correct component of the displacement vector for this case. Okay, let's go to the next problem. It says, during relay race, a runner A runs a given distance due north and then hands off the baton to runner B, who runs for the same distance in southeasterly direction, so just like the problem we've seen before. The two displacement vectors are shown in the drawing. Are they equal? So two vectors are said to be equal when they have not just the same magnitude, but also the same direction. So these two vectors are not equal because they have the same magnitude. Is that okay? He runs for the same distance, but in an southeasterly direction. It's not the same direction as due north, so it's not the same vector. So they are not. So no, because for two vectors to be equal, they must have the same magnitude and point in the same direction. Is that okay? Yeah. So the rest are not correct. Only this D is correct for this one. Okay, next. So it says, suppose the vectors A and B in the drawing have magnitude of 6 meters and are directed as shown. What are AX and BX, the scalar component of A and B along the x-axis? So you want the AX component. Sometimes they can ask for the Y component. So you just complete this triangle, okay, like this. So for A, I have this triangle, right angle triangle. So this is AX and this is AY. So A is 6 meters at an angle of 35 degrees. So this is a right angle triangle. So to get the x component, this is the x part is adjacent over hypotenuse. So it's going to be cosine 35 degrees is ax over 6 meters, 6. So ax, the x component, is 6 times cosine 35 degrees. Is that okay? 6 times cosine 35 degrees. So you take a calculator again. Excuse me. So you find cosine 35 degrees. So you do cosine, make sure your calculator is in degrees, not in radians or any other thing. Cosine 35 degrees, that will give you 0.8191, then times 6, 4.915, so just 4.9. So 4.9 meters is AX. But don't forget that this is 0. Is that okay? And this component is in the negative x-axis. So this is y-axis. So I have to put a minus sign there. Minus 4.9 meters. Is that okay? So AX is minus 4.9 meters. Okay? So this one is correct, minus 4.9 meters. This one is also correct, minus 4.9 meters. Now for B, B is in the positive side. So the x component of B will be positive x. The x component of A was negative x. Okay, I'll tell you another way, another simple way to do this. So there are two ways to look at this. Okay, now let's look at, for B part, I already know it's the 6 cosine 35 in the positive direction. So for the B part, it's just going to be, Bx will just be plus 4.9 meters. Okay? So it's minus 4.9 for A and plus 4.9 for B. Okay, let me tell you the other way to do it. If you are confused about which side is minus and which side is plus, just take your angle, all your angles to the positive x-axis. So for Bx, it will be cosine 35 times B times the angle to the positive x-axis. For Ax, it will be cosine 180 minus 35. That'll give you 145, 55, 65, 75. Yeah. Is that okay? So 145. So it will be 6 cosine 145. If you do 6 cosine 145, you see it gives you minus. So the minus will come automatically. But if you use cosine 35 on this side, you are working in this minus side. You have to put in the minus yourself. You have to understand there is a minus and put it there. Is that okay? But if you are using the angle to the positive x-axis, which is 145 to the positive x-axis, you don't need to worry about the minus. The cosine 145 will bring the minus for you. Okay? You're going to see more of these problems and how to work them as we go along. Okay? So let's go to the next problem. And before I forget, in getting components, let me just tell you the trick to getting components. So if I have a vector here, 6 meters, and an angle to the x and y axis, say theta, if I'm looking for the x component, if I know the angle it makes with the x-axis, I take the cosine to that angle. That's instead of drawing a triangle and trying to think. So this is 6 cosine theta for AX, for example. So this is vector A. And AY will be 6. I just changed the cosine to sine. That will give me my AY. But if I'm using this angle here, if the angle was here, if the theta was here, say alpha, I can also use alpha to get the component. But because alpha is now to the y-axis, the axis that has the angle always cosine. So I will use cosine alpha for y. So 6 cosine alpha is also AY. It will give me the same thing. And 6 sine alpha is AX. So it depends on the angle you are using. So it's not that vertical is always sine and horizontal is always x. No. It depends on the angle that has the axis. So if I know the angle to which the axis I'm looking for, I use cosine of that angle to that axis that has the angle, x or y, and use sine of that same angle for the axis that doesn't have the angle. That is the trick. We're going to practice more with some other problems. Let's go to the next problem. Okay, so I'm going to do chapter 01, problem 01 first, and then I'll go to the remaining two. So we're doing chapter 01, problem 01 now. Let me wipe this off. So problem 01 says, a student sees a newspaper ad for an apartment that has 2230 square feet of floor space. How many square meters of area are there? So here you are converting 2230 square feet to square meters. 2230 feet square to square meters. So how many feet are in 1 meter? So that's the first thing. You can look it up. I think it's about 3.28. So look it up. How many feet are in 1 meter? Just to be sure. So, how many feet are in 1 meter? Okay, so let's see. So 1 meter is 3.281, if I'm correct. So here you want feet square. You want to convert feet square to meter square. So you say 1 feet is 3.281 feet is 1 meter. So feet, we cancel one of the feet, but we want feet square, so we'll do it again. 1 meter, 3.281 feet. So in the bottom I have feet times feet, which is feet squared. We'll cancel the foot, and here becomes meter squared. Since 1 meter is 3.81 feet. So this is how you cancel. Feet square cancel feet, feet. So I have 2230 divided by 3.28 times 3.281. All now is meters times meters, meter squared. That is how you convert. Very easy. Okay? So I do 2230 divided by 3.28 divided by 3.28 again. Okay, so I do that in my calculator. So I do 2230 divided by 3.28 divided by 3.28, 207. Okay, gives me 207.22 meters squared. That's all. That becomes the answer there. Okay. Okay. So now let's go to the next. Let's see. The next is chapter 01, problem 02. It says a bicyclist in a tour. Is that okay? A bicyclist, I hope you guys can see the problems clearly. Let me make sure. Yeah, okay. A bicyclist in the Tour de France has a speed of 31 miles per hour on a flat section of the road. What is the speed in kilometers per hour? Okay, so you want to change miles per hour to kilometers per hour. So you look up how many kilometers are in 1 mile. Is that okay? So you do kilometers to miles. Is that okay? How many kilometers are in 1 mile? 1.61. So I have 1.61 kilometers in 1 mile. So that's all I need to solve this problem. So this is another conversion problem. So 1.61 kilometers equals 1 mile. So that's what I'm going to use. So I want to convert 31 miles per hour, miles per hour. I want to convert that to kilometers per hour. So I now do this. I want kilometer on top. So I'll put 1.61 kilometers is 1 mile. So mile cancels mile. So I have kilometers per hour. And I'm done. That will give me kilometers per hour already. Simple. So I leave hour the way. So the answer becomes 31 times 1.61 kilometers per hour. So I do the 31 times 1.61 really quick. So I do that in my calculator. 31 times 1.61 gives me 49.91. 49.91 kilometers per hour. Problem solved. Okay, 49.91 kilometers per hour. And that's the end of that problem. But we have the B part. So let's see what the B part says. Okay? The B part says convert the same to meters per second. So I'll just convert this kilometers per hour because it's the same as 1.31 miles per hour. So I'm converting 49.91 kilometers per hour to meters per second. So I know 1,000 meters is 1 kilometer. So kilometers cancel kilometers because I want meters on top. Then I know that 1 hour is 60 times 60, 3,600 seconds. Hour cancels hour. Whatever I multiply and divide is remaining meters and seconds. So it becomes 49.91 times 1,000 divided by 3,600 meters per second. And that solves the problem. So I do 49.91 in my calculator. 49.91, my calculator keeps hiding, times 1,000 divided by 3,600. 13.86. So 13.86 meters per second. So that's what that gives you. And that becomes the answer for the part B. Okay? 13.86 meters per second. Okay. So let's go to the next problem. Oh, sorry, I haven't finished the problems on that side. So now we're doing this one. So given the quantities 3.3, B is that, C is that, what is the value of the quantity A cubed over CB squared? So that's a straightforward algebra. So it says we're looking for, so A is 3.3 meters, B is 3.2 seconds, and C is 95 meters per second. So beware of the units, okay? So we're looking for D, which is A cubed over CB squared. So that will give us 3.3 cubed. You are cubing also the unit over C, 3.2 seconds times 95 squared meters per second also squared, so that we can tell the units, okay? Because we're going to tell what the unit is. So I have 3.3 cubed divided by 3.2. This is seconds, so let me put this in brackets, okay? Seconds, so you don't. So I do the numbers first, okay? I do the numbers first. And doing the numbers first, this will give me 3.3 cubed, okay, divided by 3.2. Oh, I flipped it the other way. You see, you have to be careful. I was making a mistake. So it's A cubed over CB squared. I did A cubed over BC squared, okay? So it's CB squared. So C is not squared, it's B that is squared. So 3.2 squared, okay? Okay, so I make that correction. So divided by 3.2 gives us that. So now let's do it again. 3.3 cubed divided by 3.2 squared. And then divided by 95. 0.037. So this is 0.037. So what is the unit? So let's do the units. It's meter cubed divided by seconds squared times meters per second. So the seconds here, we cancel the seconds. It's meter cubed divided by meters seconds. So meters cancel one of the meters, becomes meters squared per second. Okay? So the unit is meters squared per second. Okay? So I hope that is clear. Let's go to the next problem right now. That is this one here. A hill that has a 36% grade is one that rises 36 meters vertically for every 100 meters of distance in the horizontal direction. At what angle is such a hill inclined above? So they are just looking for an angle here. So let's do that really quick. Okay. So is one that is for every 36 meters vertical, it has 100 horizontal. So they're asking, what is this angle theta? Is that okay? Above the horizontal. So this is going to be a right angle triangle, opposite of adjacent. So tan theta is 36 over 100, 0.36. So what is theta? Is the tan inverse of 0.36. So that's all you do. Give me about 20 degrees, I think. So let's look at that. So we'll go to our calculator again and press shift tan of 0.36. 19.79 degrees. Okay? 19.8 degrees. And that's it. So let's go to the next problem. So the next one is 1026. Vector A has a magnitude of 74 units and points due west, while vector B has the same magnitude and points due south. Find the magnitude and directions of A plus B and A minus B. So we have 74 due west and same magnitude due south. Okay, so let's do that. So 74 due west is like this. So this is west, 74. And due south also 74. Is that okay? So 74 units is anything, meters or force or whatever. So we are looking for A plus B. So A plus B, so you are doing tail to tail, so this will work. So for A plus B, this is A and this is B. So A plus B means I draw A this way, I draw B tail to head. So this is A plus B. And my resultant will be from head to tail, like that. Or tail to head. So this is my resultant, from the starting one plus B to the ending one. So this is A plus B. Is that okay? So it's going to be R, so there's 74, 74. So R squared is 74 squared plus 74 squared. So R will be square root of that. Okay? So what will be the direction relative to due west? Oh, so they want a specific direction. So let's get the magnitude first. 74 squared plus 74 squared and the square root. So 74 squared plus 74 squared. It gives us 10,952. Take square root of that. 104. No. 10,952. 104.7 units. So what is the direction? Due west. So this is west. So direction due west will be here. If they wanted a direction due south, I will use this. So this is the angle I'm looking for, theta. So I'll do tangent of theta is 74 divided by 74. So it's just 74 over 74, which is 1. So inverse of that, theta is 45 degrees. Only 45 degrees can give you same. And you can tell. So 45 degrees. So what angle is this? So it's 45 degrees. This is west. Is that okay? This is south. So it's 45 degrees south of west. But it's the same 45 degrees here, which is west of south. Because 45 degrees is the only one that has that special angle. Okay? That's why sometimes it's called southwest. So you can just say southwest because it's 45 degrees. Or west-south. So it's going to be 45 degrees south of west. So we are looking for A minus B now. That's the next question. So let's do A minus B. So A is going due west, B is going due south. So minus B will be going due north. So this is minus B. So this is A minus B. Still 74 units. So what is the net? The net is going to start from here and go like that. So that's my R. So I use Pythagoras, I'll get the same result, 104. What direction due west? I find this angle, due west, because this is west. I'm still going to get 45 degrees. It's going to be 45 degrees north of west, because this side is going to the north. So 45 degrees north of west. Okay? Okay? So don't confuse this. Let me go a little bit to explain this to you about the angles. It's really important that you understand what's going on here. So this is north, east, west, south. An angle here, theta, is called theta alpha. So what is theta? Theta is north of east. Theta is an angle north of east. So it means start from the east, move theta towards the north. Alpha is east of north. So it means start from the north, move alpha towards the east of north. Okay? So don't get it confused. Okay? When they say north of east in symbols, they will write it like this. You start from east, move theta degrees towards the north. This is how you write north of east. Don't confuse. This is not east of north. This is north of east. Start from east, move theta towards the north. East of north is the opposite. Start from north, move alpha degrees towards the east. So this symbol of this, and this is symbol of this. If they say northeast or southwest, that is 40, they won't give you an angle, that is 45 degrees. That is midpoint between north and east. So that's how you know the angles, just in case, for direction purposes. Okay, let's look at the next problem. This is the last problem, I think. So we are given magnitude of 4 vectors, A, B, C, and D, and we are asked to find the magnitude and direction of the resultant. So I'll teach you 2 ways of solving. There are like 5 different ways, but some of them are a little advanced for you. I'll teach you just 2 ways. Whichever one is simpler for you to solve the problem, you use it to solve the problem. Okay? Okay. So let's look at the first way to solve this problem. Okay? The first way to solve this problem. So my A is 14 meters. Okay? So the first way is to get all the x components. I call sigma, let me call it just sigma x. All the x components. So A is going to the negative x-axis. So I told you once I know the angle to the axis, I take cosine of that angle. So it's going to be A cosine 20 degrees, but minus. So A is 14, so it's minus 14 cosine 20 degrees. Then B has no x component because B is directly a vertical thing. So it's plus 0 plus C is in the negative for the x component. C cosine 35 degrees. So C is 12. So it's going to be minus 12 cosine 35 degrees plus the x component of D. D to the x is 50 degrees. So it will be D cosine 50. 50, D is 26. So 26 cosine 50. Okay. So I do that in my calculator really quick. Okay, so I do 14 cosine 20. That'll give me 13.16. So this is minus 13.16 plus 0 minus 12 cos 35. Minus 9.83 plus 26 cosine 50. 16.71. Okay. Then I sum all those together. 16.71 minus 9.83 minus 13.16 give me minus 6.28 meters. Good. Now let's go to sigma y, their y component. So I go back again. A is cosine 20 to x, so it will be sine 20 to y, and it's positive y. So it's 14 sine 20. B is already in y, so just plus b, positive b because it's positive y, so plus 11. C is cosine 35 to the x negative, so it will be sine 35 to the y negative, so it will be minus, I just put the minus in here, minus 12 sine 35. Then D is cosine 50 to the x, so it will be sine 50 to the negative y. So it will be minus, D is 26 sine 50. So I do that here. 14 sine 20 is the first term, so I do it on my phone. 14 sine 20. 4.79. So it's positive because it's going, when I take the y component is in the positive. Y component of this negative. Y component of this is negative. Okay. Then plus 11 minus 12 sine 35. 12 sine 35. 6.9 minus 26 sine 50 is the last term there. 26 sine 50. So 26 sine 50 gives me 19.9. Good. So I do 4.79 plus 11. That's 15.79. Okay. 15.79 minus 6.9 minus 19.9 minus 11.01 meters. So I have two negatives. X sum is negative, Y sum is negative. So it means I will draw all these vectors will return to only 2. The sum X is negative, so it will go to the left 6.28 meters. And Y is negative, it will go down 11.01 meters. If X was positive, I would draw it this way. If Y was positive, I would draw it. So you can have 4 different kinds of things. But this is the situation we have. Is that okay? So what is my net? So to get my net, I have to do tail to head. So I'll draw this down here, which is the same. And draw this like that. Is that okay? Is that okay? So this is minus 11. So I don't put the minus anymore. I just say 11.01. So after drawing the diagrams like this, I don't put the minus anymore because I've taken care of minus, and this is my resultant. Is that okay? This is my resultant, or my net, from tail to head. Okay? From tail to head. Okay. Now, how do I get this resultant and direction? So, from the positive x-axis. So, they want the direction from the positive x-axis, from here, like this, to positive x-axis. So, I need to find this angle first and add it to 180 degrees. But let's get the resultant first. So, our resultant R would be square root of 6.28 squared plus 11.01 squared. Okay? So do that in your calculator. So 6.28 squared plus 11.01 squared. That gives us 160. Then take a square root of that. 12.68. 12.68 meters. That's my resultant magnitude. So what's the direction? So let me find theta. So tangent of theta is opposite 11.01 over adjacent 6.28. So 11.01 divided by 6.28, 1.75. So what is theta? Is the tan inverse of 1.753. Okay, shift tangent of answer 60.3 degrees. So add that to 180. 240. So the total angle we are looking for is 240.3 degrees. Okay, so that becomes the final answer. 240.3 degrees, and the magnitude is 12.68. Okay, and that is the end of the homework for homework 1. And then just go through, and there are several methods for solving this problem. Is that okay? Several different methods for solving this problem. Okay? Okay. So let me tell you another method for solving this problem before I go. So whichever one is easier for you, you can use it. We'll get the same answer exactly. So let's try. That's another way to confirm our answers, okay? It's another way to confirm our answers. So for that, for the second one, you draw a table. Here you have vectors. Here you have x component, and here you have y component. So this is x component, and this is y component, and these are the vectors. So I start with A. A is 14. B is 11. C is 12. And D is 26. So I write them down. For this method, I will use angles of each vector to the positive x-axis. That is the trick to using this, and it's the simplest method, but you should know the trick. The trick is everything you are measuring is to the positive x-axis. So I'm starting with A. For x component, what angle does A make with the positive x-axis? So it's 20 here, so here is 160 to make 180, so 160. So it's going to be 14 cosine 160 degrees. I put my answer there. 14 cosine 160 degrees. So I press my calculator. 14 cosine 160 degrees. 14 cosine 160 degrees. Minus 13.2. Minus, so I put the minus there. Minus 13.2. Then I go to B. B makes an angle of 90 degrees with the positive x-axis. So B is 11 cosine 90 degrees. So to give us 0. Because cos 90 is 0. Then C is 12 at an angle of 180 plus 35. So I do 180 plus 35. That's 215 degrees. So I do C 12 cosine 215. So I'm going to keep using cosine for all the x component. That's the trick. Cosine of the angles they make to the positive x-axis. So 12 cosine 215 degrees. I put that in my calculator. 12 cosine 215 degrees minus 9.83. Minus 9.83. I put it there. Then for D, D is an angle of, this is 50. 360 minus 50, 310. So it's 26 cosine 310 degrees to the positive x-axis. I'm always going counterclockwise to the positive x-axis. So let's do 26 cosine 310. $16.71. Good. Then I sum all this together. For the x, 16.71 minus 9.83 minus 13.2. 6.3. Remember we had 6.28 the other time, so it's approximately minus 6.3. So it's minus 6.3. That's my total x. So it means what we did the last time was correct. Go 6 minus 6.28. Now let's go to the y. For the y, I don't look at the diagram anymore. Okay? Let me make sure you guys can see this diagram clearly. Okay. For the y, all you need to do is just change all these cosines to sines. Since you've taken the angles to the positive x-axis. So this becomes 14 sine 160, 11 sine 90, 12 sine 215, and 26 sine 310. Just change all the cosines to sine. So let's do that in our calculator. So I have 14 sine 160, 4.79. Take note of the minus. Anywhere there's minus, put it there. 11 sine 90, sine 90 is 1, so this is 11. 12 sine 215 minus 6.9 and 26 sine 310 minus 19.9. Now let's sum all this together. Minus 19.9 minus 6.9 plus 11 plus 4.79. 11.02 or 11.02. This sum of y, which is minus 11.02, sorry. So you see that's the same thing we got. So you put this minus sigma x to the negative x-axis minus y to the negative y-axis, and you sum them together, you get your net like we did. So every other thing else becomes the same from the way we did before. So the trick is how to get your sum of x and your sum of y. You can either understand it from the diagram if you know how to get, and noting that this is minus and this is plus, cosine 20, sine 20, cosine 35, sine 35 minus, cosine 50, sine 50 minus. If you know like that, fine. If you don't, draw the table and take each angle to the positive x-axis, take cosine for x component and sine for y component and sum. There you don't care about the minus. The cosine of the large angles or sine of the large angles will bring out the minus themselves. Okay? But if you are using the angle in here, you have to remember there is a minus sign to this side. And that's the trick for this problem. So thank you for the end of homework 1, and I'll see you for homework 2 and recitation.